Okay, let me start the class by saying good evening once again. Tonight we're going to look at the fundamentals of CNC machines, that is, computer numerical control machines. First, we want to start by looking at the machine coordinate system designation. That is, if you take a typical CNC machine, what we want to understand is how is the coordinate system designated on the machine. Let's take let's say a CNC mill, a CNC lathe machine. For instance, if you take the CNC lathe machine, the CNC lathe machine actually positions the z-axis of that machine. If you look at the z-axis is on the spindle axis, and then the x-axis is actually on the machine tool axis. So if you look at this right hand designation here, the middle finger is pointing towards the spindle axis, and then this thumb, because we drawing basically the thumb on the two-dimensional plane, this thumb is supposed to be facing us directly. So if you try to use your three fingers, your thumb, your middle finger, and the forefinger, if you orient them at right angles, then you have the thumb facing you. That shows the direction of the two axis, and then the middle finger actually gives you the direction of the spindle axis when it comes to the CNC lathe machine. Okay, now when we come to the CNC mill machine, that designation is a little different. Yeah, that designation is a little different. Now, if you take a CNC mill, the CNC mill, the longest travel, that's the slide, is the x-axis. We will come to the CNC mill designation. So I just want to use this slide to just explain the CNC lathe, where the z-axis actually shows the direction of the spindle axis. The x, the one pointing towards me, that's my thumb, and then of course the y is the vertical axis. Now, if you take a CNC mill, the CNC mill has a spindle that actually takes the tool in a vertical direction. So on a CNC mill, the x and y axis are literally an axis that is designated along the travel of the mill, and then the z actually is the vertical, which actually holds the tool, and the y is the travel right into the bed of the machine. So I will show you the designation when we get to the CNC mill very shortly. Now, if you want to determine the direction of rotation of the tool, of the spindle, then you want to determine a positive or clockwise direction. It's basically like showing how the hand is displayed in the video. If I point my thumb up and I try to curl my hand towards me, that shows the direction of the clockwise movement of the machine tool, or the spindle, sorry. So that is a clockwise rotation. That is curling my hand this way. I show a clockwise rotation. Now, if you take a typical spindle, either maybe a drill or a mill, Then if I point my finger up, showing the direction of the axis, and I curl my hand, I get the clockwise rotation of the spindle this way. Now if I point my thumb this way, maybe I want to show that of a lathe machine. I put my thumb along the direction of rotation of the spindle, and I curl my hand that way. Then what I'm actually showing is the direction of rotation, the clockwise direction of rotation of the spindle. And that is how you determine the direction of rotation if you take any machine like a CNC lathe or a CNC mill. Now, if you take a typical CNC mill, this is the axis and motion nomenclature. The x-axis has the longest travel. That is the mill. That is the x-axis. That's the distance here. Travel on the x-axis. Now, the travel on the y is along this axis, and then the z is also along this axis. Okay, in some other nomenclature, this may change a little bit, but the vertical column is the z. But the x and y in some type of mill do interchange, so you may have the x along the longest travel and then the y on the shortest travel, or you may have the other way around. Okay, now we come to the axis of motion of, let's say, typical vertical CNC machine. Then on the vertical CNC machine, you will have the y as the travel into the machine bed, which is the shortest travel, and then you will have the x, actually the travel, the longest travel on the machine bed, and then of course the vertical axis becomes the two axis or the spindle axis. Okay. Now when you take analysis of motion of a contour mill CNC 5-axis CNC machine. This is a typical 5-axis CNC machine. Now for a 5-axis CNC machine, you have the two posts here. Now you can have the two having the potential to rotate along or above the axis of the two posts itself, or the spindle itself, or above the axis of the spindle stand, or what is called the spindle. Now you can also have the spindle itself rotating about its own axis. Okay, and also you can have it in this direction, that is rotating about here. That is, so you have, apart from the x, y, z axis, which is the 3 axis, you can have a 4th axis, you can have a 5th axis. So you can have a rotation of the spindle this way, and then you can have a rotation of the whole unit which carries the spindle. Okay. Now, if you go on to look at the nomenclature of the CNC lathe, this is what I was explaining previously. The Z axis is parallel to the spindle, and the longer, that's the longest axis, longer than the X axis. So if you have a typical CNC lathe, then you have these as the X axis and these as the Z axis. Okay, so that is how a typical CNC lathe the axis nomenclature looks like. Okay, now When it comes to the Cartesian planes, depending on how you email or the orientation of the plane that you are actually machining, you will have a coordinate. Sorry, you have a code that is assigned to the orientation of the plane or the plane that the tool is working in. So, if for instance you are working or you're machining in an XY plane, then if you are going to program your machine, then you need to issue a command which is called a G17, which is showing that your machine is basically working in the XY plane. If you are working in the XZ plane, then you will have to issue a command G18 to show that you are working in the XZ plane, which is the vertical plane here. If you are working in the YZ plane, then you will have to issue a command G19 respectively on the middle, just to show that your tool is actually working in this plane. So, if you come to the plane designation, that is what we say about that. That's the Cartesian plane designation. Now, there's one important, point on the CNC machine or on every CNC machine, which is called the part reference 0. Now, it is very important for all CNC machines to have a reference point which to base their coordinate system. Now, if you have any CNC machine, it's important that you should be able to identify a reference or a zero position that you can start programming the coordinates from. And the point is, it is generally easier to use a point on the workspace itself for reference, as maybe a path reference during the examination. So it is very important to set a path reference 0, especially on the workpiece, so that you know that okay, if I start from the workpiece at this point, this is my 0 position, and if I advance this distance, this is my X position or my Y position. Sorry, this is my X distance or my Y distance. So you try to do that in such a way that you can start programming the machine based on a reference coordinate point that you have set, and which will obviously not be changing. Okay. Now, when it comes to the Cartesian graph, we're going to look at that for milling and turning, looking at the Cartesian coordinates very shortly. Now, if we move on to look at, let's say, the CNC mill, we have two main coordinates that we use in programming CNC machine, or two main coordinate types, which is absolute coordinates and then what we call incremental coordinates. So first, let's talk about the absolute coordinate designation. For the absolute coordinate means that any point on your Cartesian graph, you measure the distance from the origin to the point. So let's say a typical absolute coordinate system is what we have here. If we want the point A, the point A measurement is taken from the origin, and we say that we go 4.5 units here, and then we go 1.5 units here. So that is from the origin. If you go to B, we are also taking B from the origin. We move 3 units up here, and then 2 units down here, and we locate B. Now, all the coordinates are being referenced from the origin. And that is why it is called the absolute coordinate system. That is, it has an absolute coordinate, an origin for all the coordinates. They take an origin from a common point. Right. Now we have the absolute coordinate system. We have what we call the incremental coordinate system. The incremental coordinate system is more like a relative coordinate system. In a relative coordinate system, what you're basically doing is that you have, let's say this is our first coordinate point, 1, 3, taken from the origin, 1, and then 3 is up here. And the second coordinate, which is this, actually depends on the relative position of this from the second coordinate, not from the origin. So point 2 is going to be, okay, what's the difference between the x coordinate and the new x coordinate in this position? You move from 1 and then you went through -1. So your actual movement is actually 2 units in the negative direction for the x. And then you notice that you have 3 and then you drop to 2. And so your relative movement in the z or y direction is 1 unit in the negative y direction, which gives you -1. So then the relative coordinate of this point is going to be -2, -1. Now, the same with the third coordinate, you will take its final coordinate from the previous coordinate, which is the second coordinate. So the new coordinate position of the third coordinate will actually have the difference in terms of the movement from -2 all the way down to 0.5 or 0.25. Now, what it means is that x has really moved from -2. If you look at what we have here, it's -2.75. So if you have this as minus position -1, and then this position is -3.75, then you ask yourself, okay, from -1 to -3.75, the difference is -2.75. And so it is taking its coordinates relative to the previous coordinate. That is what is called a relative coordinate system. Okay. So when it comes to the fundamentals, we are looking at CNC turning fundamentals, like the CNC lathe machine fundamentals. Now, for the CNC lathe, the absolute zero is actually positioned if you have, let's say, a blank that is inserted into the CNC lathe. Then you have the absolute zero position set at the geometric center of that particular part. So the zero position will be at where I am displaying the cursor. And then you will start programming from that center toward the workpiece to actually ensure the material removal and all that. So that is why we position the zero or the path reference zero on the CNC lathe machine. Okay. So in the CNC lathe machine too, what you can do is you can program the tool in two ways. That is, because we are turning a part. When we turn a part, we are basically generating a diameter cross section. So the system, the part drawing or the part or the blank will be rotating And so once we actually take off, let's say this portion, it automatically gives, gives the other view or the other image to the other side. So if you want to program ways, we can use two main ways to do that. We can program for diameter, we can program for radius. So if we program for diameter, then let's use this as an example. Then if the workpiece has 5 pins outside diameter, and you want to command the absolute movement of the outside, move to the outside, you will program x equals 5.0. That is, you are using the diameter program, and then you are giving x equals 5.0. And the system will see it as the diameter already. But if it has work with radius, it will just split it and come down with the radius. Now, if it comes to radius or radial programming, if you are using that syntax or that format, the radius or radial relates the x-axis to the radius of the workpiece. So, for example, if you want a 5 inches outside diameter workpiece, then you program the x to be 2.5 to move the 2 to the outside. So that 2.5 on both sides, you are going to get your 5.0 as your radial programming. Now we have absolute coordinates system. Now let's just basically use this drawing here to try to fill out these P1 and P2 in the lines. Now, if you take this particular drawing, this P1, let's say point 1, will be here, and then we shall have point 2 here, then we shall have point 3 up here, point 4, point 5, and then point 6 will be down here, and then point 7. So you notice that we can actually create 7 coordinates, okay, and we are starting them as absolute coordinate system. So we start off at 0 here, and because we are programming on the late, for a programming on the late, the 2 start at 0, 0, the work position at negative z. So any movement on the z axis is seen as a negative movement into the workpiece. So that is basically some fundamentals here. We look at the incremental coordinate system. If we want to use incremental coordinate system, perhaps we start the program and we evaluate the analysis a particular value, maybe 0.5. Now 0.5 from where? From the origin. Now if we are using incremental coordinate system, then our next coordinate, which is this, which is going to be the same y, which is 0. The same x, we'll call the same x, which is 0.5. Then we'll have a z, which is minus 2. Okay, so we can build up an incremental coordinate system. Now, if we have this, which is 0, then we'll call this going to be minus. Of course, if this is 0, then this is going to be a minus, the z is going to be a minus 1. And then the x is going to be a half. Okay, now when we move on to this point will have no change in the x. So that is going to be 0 for the x, But for the z, it changed from -1 to -2. And so the relative coordinate position of this is going to be -1 because it's from -1 to -2. So we say that incremental relative coordinates, they use each successive point to measure the next coordinate instead of constantly referring back to the origin. The incremental offers like a good opportunity to sort of program from one point, and then the next point will depend on the previous point. Now, at this level, you may not appreciate that, but incremental coordinate system is important when you have a very complex part that you are programming. Then you start an incremental coordinate system, because when you are using incremental coordinates, your new coordinates has to all have only a relationship between the previous coordinate, not from the origin. So you are not going to do any sort of measurement from the origin to be able to achieve what you need to achieve. Okay, so we move on from the absolute coordinate to and then the incremental coordinates. We, by way of some self-assessment, I want you to try this. We have a grid page. That grid page has some number points here: 1, 2, 3, up to about 10 or to 14. Each of the number points actually gives you an idea of the coordinates. So if let's say you take for instance 1, each grid is 1 unit. So the x travel is 1, 2, 3. The y is 1, 2, 3, 1, 2, 3. So for 1 it is 3, 3. You come to 2, the y is actually negative down here, and then the x is also having a certain value. So this one too, you can take the value there. So you try and collect all these values for absolute coordinate system. Then the next task is to write some points in the incremental coordinate system. Now, for an absolute coordinate system, the software, the CNC machine issue a command called G90 for absolute coordinate system. And then for incremental, the CNC machine use a command line G91. Okay, so I want you to try this assessment by just looking at this and try to write out the coordinates for x and y, and then you take out the coordinates for from 8 to 9. That is, we are looking at incremental coordinates between 8 and 9. So what is the coordinate of 8 and what is the coordinate of 9? What is the real distance? What is the real difference in terms of relative position? So I want you to try that exercise to populate this slide to talk about the relative coordinates and then the incremental coordinates. Okay. So unfortunately, we have to end the class on this coordinate designation. As I said earlier, we will continue tomorrow by looking at unit number 4, which is the programming using CNC milling centers, where we are going to take every single command or code, and then we explain what they mean and all that, so that we will then start some exercise on the CNC programming, where we can now program and actually simulate to see how it functions. Okay, so It's unfortunate we had to end the lecture tonight because we basically to on this slide, but as I explained tomorrow. So thank you and have a good night.